just one of 100 billion planets orbiting 400 billion stars that make up an immense galactic spiral. Our home, the Milky Way. Galaxies are where stars form, and of course planets form around stars. So the story of the Earth, of yourself, of the solar system, has everything to do with the story of the galaxies. Our galaxy's story began 13.6 billion years ago, just after the Big Bang. It was a time when there were no planets and no stars, just a vast lumpy soup of superheated hydrogen gas. Over millions of years, the temperature dropped, and gravity compressed the lumps down, until eventually the hydrogen molecules fused and ignited a star. In time, billions of stars burst into life, and the Milky Way started to take shape. You can think of a galaxy as sort of like a human being. When you're young and in your adolescent stage, you're vibrant and active. That's a young galaxy forming stars in a crazy way, and it's not even fully formed yet. At a certain point, a galaxy reaches middle age, and a middle-aged galaxy really is what it's going to be. It has its shape, but in the long run, a galaxy will stop forming stars, and eventually, just like we all die, our galaxy will die. So, at what stage of life is the Milky Way? Is it a healthy, active young galaxy, or is it heading for its deathbed? Scientists can determine a galaxy's stage of life by its color. So we see different colors of galaxies in the universe. We see galaxies that are tinted blue and galaxies that are tinted red. When we see a blue galaxy, that tends to be a younger galaxy full of bright, hot, newly formed stars. When we see a redder galaxy, that tends to be a dimmer, older galaxy that isn't forming new stars in the present moment. All its stars are aged and older and redder, and so the entire galaxy casts a different hue. So what color is our galaxy? It's a simple question, but the answer is hard to come by, even though we've been looking at the Milky Way for thousands of years. The term Milky Way is ancient. It goes back to a time when in the dark sky, people noticed there was this light band that actually went from horizon to horizon. And that band turned out to be made of thousands and thousands of stars, actually too far away to see individually. But it took us a long time to realize what the shape and the scale of the Milky Way galaxy is. The amazing thing to think about is that we actually don't know our home galaxy very well at all. We actually live in the middle of this disk of gas and dust, and that obscures our view of the larger Milky Way. Using visible light, we can't even see to the center, let alone the other side of the Milky Way galaxy. The solution is to use a form of light that passes through the gas and dust. Infrared. This is the Sloan Digital Sky Survey Telescope at the Apache Point Observatory in New Mexico. It's mapping the galaxy using infrared and giving scientists unprecedented insights. The first sensitive infrared observations really weren't done until the last 15 years. And each of these new windows on the universe teach us different things. In the last 15 years, Sloan has surveyed more than 250 million stars, analyzing their light to work out the color of the Milky Way. And what scientists saw shocked them. Until very recently, we thought the Milky Way was a young, healthy galaxy. But now there's evidence that we may be entering the pathway to death. The Sloan telescope revealed that star production in our galaxy is rapidly dropping. The Milky Way is dying, and when it stops forming new stars, its time will be up. Paradoxically, our galaxy still has enough star-forming gas, so it should be healthy. Yet something is killing it off. So the Milky Way galaxy is this wonderful disk filled with rich hydrogen gas, lots of dense dust clouds. It has everything you need there for star formation, but it seems to be slowing down and even turning off. And right now we don't really understand what the culprit is. The Milky Way has been producing stars for billions of years. But just how old is our own star, the Sun? Is it a relatively new star in our galaxy? Our own Sun formed about 4.5 billion years ago in the Milky Way galaxy, and we are not the oldest star by far. And yet, tragically, we actually seem to be one of the last generations of new stars in the Milky Way. Current projections suggest that in about 4 billion years, star formation may have ceased altogether, which is almost just the blink of an eye in the life cycle of the universe. To find out why, one crucial question needs to be answered. How is the Milky Way dying? To kill a galaxy, you have to get rid of the cold gas, because that's what stars form from. There are many ways you can do this. You can blast it out from the inside. You can draw it out from the outside. You can heat it up so it's no longer cold. You can use it all up. And there's even more ways you can stop it. What we have to do is figure out which way is happening in our galaxy. Perhaps the culprit is inside the Milky Way itself. A clue comes from another galaxy entirely. This is W22460526. Scientists call it a hot dust obscured galaxy, or hot dog for short. This galaxy is 12.5 billion light-years away. It's the most luminous galaxy we know of in the universe. It has a light of 300 trillion stars. The source of the intense light is not its stars, but a mysterious object at the galaxy's center. It's 1 million times smaller than the galaxy itself. And there's only one thing that small and that powerful: a supermassive black hole. So supermassive black holes, as the name suggests, are indeed supermassive. These are billions of times more massive than our sun. These are gigantic objects. The gravity of the supermassive black hole is huge. It sucks in incredible amounts of the hot dog's vital star-forming gas. And as the gas swirls to form a disk, the intense friction superheats it to millions of degrees, and in some galaxies, triggers huge jets. When a lot of material falls onto that black hole, it creates incredibly energetic jets that can be tens of thousands of light-years across. All of a sudden, you have this blowtorch in the middle of the galaxy. Black hole jets are bad for galaxies because they can shut down star formation. They can heat gas up, blow gas out of galaxies, and it could really kill them. A supermassive black hole is cooking the hot dog. So is something similar happening at the center of the Milky Way? In 2016, scientists at Harvard discovered damning evidence that may link the Milky Way's supermassive black hole to our galaxy's demise. Similar to the hot dog, the Milky Way is surrounded by a vast cloud of blown-out gas. And the scientists trace the gas back to its source, Sagittarius A star, our supermassive black hole. Well, it turns out our supermassive black hole had a bit of a hiccup about 6 million years ago. There's evidence that some matter must have fallen into that black hole, and if it fell in too quickly, it would have gotten superheated by its own friction. And this would have acted, in a sense, like an explosion. And that event was huge. Our galaxy expelled an incredible amount of gas, 130 billion times the mass of the Sun. Large amount of gas. This event must have been very catastrophic for the inner parts of the galaxy. Luckily, Earth is in the outer parts of the galaxy where we were able to survive this event. Has the cause been found? Is our own supermassive black hole killing the Milky Way? Yet there's a problem with this theory. Sagittarius A star has an alibi. It exploded too late. Sagittarius A star got very active, very explosive about 6 million years ago. But that's so recent, it shouldn't have really affected the star formation rates. Something else is going on. There must be another culprit besides the black hole. Studies suggest our supermassive black hole had to have been active hundreds of millions of years ago to stop all star formation in our galaxy. Sagittarius A star wasn't active at that time and thus is no longer considered the cause for killing our galaxy. So scientists have to widen their search for a different killer. Maybe the killer isn't inside our galaxy. It could be that we suffered a hit and run. Star production in the Milky Way is breaking down. A sign that our galaxy is dying, and astronomers are on the hunt for clues as to why. The Milky Way's disk is made up of 3 sections. A nucleus, home to the galaxy's supermassive black hole, a dense central bulge that's 10,000 light-years across, and the spiral arms, full of gas, dust, and billions of stars. The spiral arms should be flat, but they're rippling. Is this a clue as to why our galaxy is dying? Today, we look at the edge of the Milky Way, and we see mysterious ripples in its gas, and we wonder, what's the origin? Something must have caused it to happen. Something like that just doesn't happen on its own. The real question is why. Whatever caused the ripples didn't stay. Is this a clue as to why our galaxy is dying? Or is this evidence of a galactic hit and run? In January 2016, astronomers studying data from the Vista telescope discovered something incredible. 3 nearby stars that on their own are nothing special, except they recently left our galaxy and are traveling at over 560,000 km/h. So we've discovered these stars that are careening out of the galaxy at super high velocities. Could these 3 stars somehow be responsible for warping the Milky Way's disk? Well, absolutely not. The Milky Way is so much more massive than just 3 stars. 3 stars alone can't warp a galaxy. But those 3 stars can be indicative of more stars. They can be indicative of the presence of other stars. I'll say, but dwarf galaxy, and that can work for galaxy. Oftentimes, we're really distracted by the big stuff, like the biggest galaxies. But in many cases, it's the smallest things that matter. And these dwarf galaxies really are the case of, these really small things might be the most important things after all. 15 years ago, the smallest galaxy we knew of had about 100,000 stars. Today, we know of tens of galaxies with just 100 stars or 1,000 stars. The reason why galaxies are so small, how small they get, are cutting-edge questions. And in fact, the most populous galaxies in the universe are probably these galaxies with just a few hundred stars. There could be hundreds of millions of these dwarf galaxies in the universe, but because they contain so few stars, they're very hard to find. And spotting dwarf galaxies that are close to the Milky Way is even harder, because their stars are hidden among the starscape of our galaxy. However, there's one type of star that can give a dwarf galaxy's location away. When we look at the night sky and we see stars in a particular region of the sky, they can be all different sort of distances. It's very difficult to tell, but there are certain stars for which we can measure their distance accurately. One type is a Cepheid variable star. Cepheid variable stars are bright, so we can see them to a great distance. They change their brightness in a very characteristic way, so we know they're Cepheid variables. And based on how fast they change their brightness, we know how bright they really are, so we can tell how far away they are. So if we find a group of Cepheid variables in the halo of our galaxy, then what we know is that that's a cluster that shouldn't be there, unless there's a dwarf galaxy there. The group of stars found by VISTA were very distinct Cepheid variable stars. Dwarf galaxies are abundant, but a tiny fraction of the size of a major galaxy like the Milky Way, and thus they're difficult to detect. But these three bright stars show there's a dwarf galaxy hiding beyond the edge of the Milky Way. Furthermore, scientists can study the trio of stars to rewind the clock and track back the past movements of this dwarf galaxy. Simulations suggest that millions of years ago, this dwarf galaxy punched through the plane of the Milky Way. As the fast-moving dwarf galaxy hurtled toward the Milky Way, millions of stars appeared set to collide. Catastrophe looked inevitable, but appearances can be deceptive. If you took the sun, which is really big, it's 1,000,000 miles across, and shrunk it down to the size of a piece of pollen, the galaxy itself would be twice the size of the Pacific Ocean, and the nearest star to the sun would be a mile away. Those tiny pieces of pollen are never going to hit each other. The distances involved are staggering, because of which, at the moment of impact, most of the stars from the two galaxies missed each other entirely. But that didn't mean the Milky Way escaped unharmed. Even though the stars just passed each other, they do gravitationally interact as they come close, and this gravitational interaction sets them on a course that is different than if they were to live by themselves. In much the same way that taking a stone and dropping it into a still pond creates ripples in the water, a galaxy like this slamming into the Milky Way can create ripple effects throughout the disk. The ripples in the Milky Way stretch across tens of thousands of light years. Yet this collision wasn't enough to kill our galaxy. It only caused a minor wound. But what if this dwarf galaxy isn't the only one? What if there are others? There are a lot of dwarf galaxies out there, and it turns out collisions between these dwarf galaxies and big galaxies like the Milky Way are common. They happen all the time. Right now, there are several dwarf galaxies that the Milky Way is swallowing up. In fact, a really fun thing is that we're actually closer to the core of one of these galaxies, the Canis Majoris dwarf galaxy, than we are to the core of the Milky Way. So some of the stars that you see around you in the night sky are actually stars from a different galaxy. So what happens when all these dwarf galaxies come together and start pulling and tugging on a larger galaxy? Cosmologists believe there could be hundreds of dwarf galaxies surrounding the Milky Way. A collision with just one of these dwarf galaxies rippled the Milky Way's spiral arms. But a group of dwarf galaxies could have a far bigger and far more deadly effect. Dwarf galaxies, and the way they interact with big galaxies like the Milky Way, can inflict tremendous change in our universe. When they slam into a galaxy, they can change its structure. The Milky Way would not look anything like it looks today without those dwarf galaxies. Repeated dwarf galaxy collisions could have radically altered the shape of the Milky Way itself. Their gravitational disruptions could have created a distinctive and possibly fatal feature in the middle of our galaxy, the galactic bar. The center of the Milky Way is elongated. Instead of it being shaped like a sphere, it's more shaped like a bar, and the bar is made by stars actually orbiting in this sort of elongated way. And this bar can be bad for the health of the galaxy because what they do is help to funnel gas into the core of the galaxy. The loss of this gas could be a way of stopping star formation. The bar-shaped bulge at the center of the Milky Way sweeps our galaxy's star-building gas into the galactic nucleus. Here, it's consumed by our galaxy's supermassive black hole. Without the star-building material, no new stars can form, and the galaxy dies. So is this the reason our galaxy is dying? Are dwarf galaxies killing the Milky Way with a galactic bar? So it's possible that the formation of these bars helps turn off star formation in the very core of the galaxy. But that's just the central regions of the galaxy. That doesn't explain what's going farther out in the spiral arms. So if star formation really is shutting down in the Milky Way, it's not really the fault of the bar. Dwarf galaxies cause the Milky Way serious damage by creating the galactic bar, but they're not responsible for killing the Milky Way. The search continues, and it could take a dramatic turn. It might not be that the galaxy's being murdered. It could just be eating itself to death. Our galaxy, the Milky Way, is being slowly eradicated by something as yet unknown. Scientists have identified some possible causes, but nothing as yet has been confirmed. So the hunt for clues within the body of the Milky Way continues. Our galaxy is a hazy disk of stars, surrounded by a halo of superheated gas. It's over 100,000 light-years across, but it hasn't always been so big. When you think about things so vast, so gigantic and ancient as galaxies, you're kind of tempted to think that they're very stable objects, that they don't change much over time. But we now know that our own galaxy is the product of many smaller galaxies that came together over time, and there are other galaxies still colliding with us. We see galaxies eating each other all the time. They collide, and if one galaxy is very big and one galaxy is very small, the little galaxy falls into the big one, gets torn apart, and becomes a part of that bigger galaxy. The Milky Way might be dying, but it's still a monster foraging through the universe, swallowing smaller galaxies whole. It consumes their stars, but it also has a taste for their star-building gas, and it doesn't have to collide with other galaxies to feed off them. Now, the lifeblood of a galaxy is hydrogen gas. That's what actually creates new stars. So as a dwarf galaxy passes by the Milky Way, the tremendously massive halo of the Milky Way, all of that gas can draw off material from the dwarf galaxy, adding it to the Milky Way. So in this way, the Milky Way drains away the lifeblood of other galaxies. During its 13 billion years of existence, our vampire galaxy has feasted. Consuming the lifeblood of its galactic victims, the Milky Way has grown fat. But could this feeding frenzy be a factor in the Milky Way's demise? Once again, crucial evidence comes from the Sloan Digital Sky Survey. Their telescope maps the stars in our galaxy, but it also maps the galaxies in our universe. Looking at distant galaxies is like looking back in time, because the further away they are, the longer their light takes to reach us. We see the most distant galaxies not as they are now, but as they were billions of years ago. So when you look at these galaxies, you're seeing them as they were when they were very young, and you're seeing these galaxies as they are more recently. So you can actually look at the evolution, how galaxies change over time as the universe ages. While studying the data, scientists made a dramatic discovery. They found spiral galaxies just like the Milky Way, dying all over the universe, and what connected them was their mass. There seems to be an upper weight limit for the sizes of spiral galaxies. Up to about 1 trillion times the mass of the Sun, we see spiral galaxies that continue to form stars. But once they pass this threshold, galaxies tend to die and run out of stars. While devouring the star-building gas of smaller galaxies, the Milky Way may have grown obese, and now it could be choking to death on all it consumed. But how? Once a spiral galaxy is sufficiently big, it's going to have an incredible gravitational force, so any gas that it pulls to itself is going to come in at an incredibly high speed. That gas is going to be superheated. The superheated gas moves so quickly that it's prevented from falling into the Milky Way. The gas is too energetic for our galaxy's gravity to pull it in. Instead, it stays in the halo around the Milky Way, and our galaxy's food supply is choked off. Eventually, our galaxy will starve. This will only happen if the Milky Way is over the star-building weight limit. But how do you weigh a galaxy? One basic way we can weigh a galaxy is measure how fast the stars are moving within it. So the faster the stars orbit around the center of the galaxy, the more massive the galaxy is. This method of weighing the Milky Way relies on gravity. Fast-moving stars need more gravity to hold them in their orbits, and more gravity means more galactic mass. When scientists used this information to do the calculations, the horrible truth was revealed. We've passed kind of a critical level. The Milky Way is far too massive for its own health, and we've entered the beginning of the end. We're running out of gas, and I mean this literally. Gas clouds form stars, and as they form stars, they're used up. And so our gas tank is getting closer and closer to empty every day. The investigation into the slow death of the Milky Way is solved. The cause? The gluttonous Milky Way is killing itself. Over millions of years, star formation will grind to a halt and the galaxy will die. But could the galaxy be resurrected? We seem to be telling a very sad story. We're talking about the demise of the Milky Way galaxy, the end of star formation. But maybe it's just a little bit too soon to write the death announcement yet. Hope could be just over the horizon. In space, in astrophysics, really anything is possible. The shocking case of our dying galaxy has been solved. There was no killer. It transpires that the Milky Way is eating itself to death. But is this really the end? Could salvation be headed our way? Even if star formation has turned it off in the Milky Way now, we know that it's on a collision course with the Andromeda galaxy. They're moving toward each other at hundreds of thousands of miles per hour. A collision sounds like something that's always destructive, but that's not necessarily the case. The Milky Way's collision with our giant galactic neighbor, Andromeda, won't happen for another 4 billion years. By then, star formation in both of these galaxies will have stopped completely. But this giant coming together changes all that. As an isolated galaxy, the Milky Way is already in its wind-down phase. It's not producing as many new stars as it used to. But there is one way to generate a new round of star formation, and that's through a galactic merger event. When Andromeda gets close enough, the neutral gravity between the two galaxies will start to stretch them out, pulling them out like taffy. Stars will be pulled out into these long, looping streamers, and then the galaxies will physically pass through each other. Eventually, the two galaxies will draw back together again and merge into one gigantic galaxy. And at that point, all of these gas clouds will flash into star formation. As the galaxies merge, they'll be reborn. Two dying, spiral-shaped galaxies become a single, living, elliptical galaxy called Milkomeda. Imagine you're living in the far future of the galaxy, and you see the night sky while the Milky Way and Andromeda are colliding. It will look like a very different place. Rather than one band across the night sky, you might have two as the two disks come together. It will be a miraculous sight, but a very, very different place than we have today. When gas clouds ignite to create new stars, it doesn't just stop there. But as the new stars are born, they produce energy. It's a ripple effect throughout the galaxy. New gas clouds collide in response to that. New stars are born, and it's just a chain reaction throughout the whole system. This means our sky will light up for the first time in billions of years, and star formation will flare across the galaxy. But is it too soon to celebrate? This new round of star formation during the merger of our two galaxies, while it's very cool for a little bit, once it's over, that kind of sends the new galaxy into a death spiral. When new stars are born in this new galaxy, many of them are going to be hot, large blue stars. Eventually, those young hot stars are going to start to die. And when they do, they're going to explode violently as supernovae. And those supernovae are going to start blasting gas out of the galaxy. All the gas is gone. There's no more stuff to form stars, and that's what kills a galaxy. It will take hundreds of millions of years for Milkomeda to run out of star-building gas. Our new elliptical galaxy will then starve. But there is one final blow still to come. Another issue to consider is what happens to the two supermassive stars or supermassive black holes at the cores of the two galaxies. Well, initially they're going to orbit each other, stirring up a lot of turbulence, and they're going to combine. And because there's a lot of new hot, fresh gas, our new galaxy is going to be a quasar. And that quasar is going to turn up the heat. It's going to turn up the turbulence. And this means star formation is going to be shut off. The combined power of the supermassive black holes will help create a quasar that will tear through the galaxy. It will release ferocious beams of radiation that will blast through Milkomeda's star-forming gas. It will have only just been reborn, but our newly enlarged galaxy will be dying. Once again, vast galaxies such as Milkomeda seem doomed from the start. Their size creates too many problems for star formation, or so we thought. The more galaxies we see, the more we realize there's a lot out there we haven't discovered, and there's a new class of galaxies only recently identified. These galaxies are more than 10 times the mass of the Milky Way, and intriguingly, they're still forming stars. Apparently, we've missed something. So does this mean there is hope on the horizon? The Sloan Digital Sky Survey has spent a decade studying over 1 million galaxies, and it's discovered a rare but enormous kind of galaxy, a superspiral. These superspiral galaxies are spiral galaxies that are incredibly super. And by super, I mean they have 4 times the size, 10 times the mass, and they're weird because they exceed the supposed weight limit for spiral galaxies. So they shouldn't have new stars, but they do. They're very healthy galaxies. Scientists have found just 53 superspirals. Superspiral galaxies demonstrate that in rare situations, massive galaxies continue to produce new stars. So is this a lifeline for Milkomeda? When we think about 2 galaxies colliding, a lot of our computer models suggest that they really mess each other up. Things get very chaotic. But over time, could they settle back down into a spiral shape? And in fact, that may be what happens with superspirals. One of the clues is that many superspiral galaxies have double cores. Instead of there just being one supermassive black hole, there are actually 2 orbiting each other. The fact that we see spiral galaxies with 2 cores makes it possible that you could have a collision and still survive as a spiral galaxy. So maybe there's hope that even the Milky Way will be a spiral once it collides with Andromeda. Picture the scene. 6 billion years from now, Milkomeda drifts through the universe. Not as an elliptical galaxy, but as a superspiral. This shape means the galaxy is far more stable. The damaging heat and turbulence generated by Milkomeda's supermassive black holes can't disrupt star-building gas way out in the spiral arms. Far from dying off, our galaxy will live on, larger than ever before. We've started to make computer models about how the Milky Way and Andromeda will collide, so it's possible that these 2 spiral galaxies won't just become a big mess. We may settle down to becoming a superspiral ourselves. The Milky Way could one day be a superspiral. But that isn't the end of the story. Tens of billions of years from now, could the galaxy continue to grow? Our local group of galaxies, Milky Way, Andromeda, Triangulum, and then a collection of dwarf satellite galaxies, is gravitationally bound together, and eventually we're all glued together into a single massive object. What does this mean? This means we might be part of one of the largest structures in the universe. During its billions of years of life, the Milky Way will go through many changes. It suffers countless collisions, feasts on many smaller galaxies, and gives birth to innumerable stars. We talk about the life cycle of galaxies, how they're born, how they live healthy lives making new stars, and eventually how they die away. It's really not as depressing as that. Everything in the universe changes. Galaxies like ours are in a constant state of flux. So when it comes to the Milky Way, death really isn't the end. What we see in our universe is that there's always a process of birth and rebirth. So the future of the Milky Way is that it's going to keep on doing what it does. Galaxies are ever-changing. 10 billion years ago, the Milky Way was nothing like what it is today. It's certainly 10 billion years in the future. It'll be a very different place. Look, I live in this galaxy. I hope that it can find a way to rejuvenate itself through collisions or some other process, because that gives me some hope that it'll go on for a long, long time.